First, let me show my game demo. This is my game demo, and the size of window is 672 to 768. The background color is black. There are three types of alien on the screen. They are squid, crab, and octopus. And this is a grid of 55 aliens. The first row is 11 squids. The next two rows are crab, and the last two rows are octopus. There are 11 aliens on each row, and the grid is moving horizontally back and forth. When they move the boundary of the screen, the grid will move down and change the horizontal direction, and keep moving until they arrive at another boundary of the screen, and they will move down again and change the horizontal direction again. And the movement and animation of the sprite is simultaneous, namely the movement and animation of the sprite synchronized, just like this. And I use the texture manager, image manager, game sprite manager, box sprite manager, game object manager, sprite batch manager, and timer manager in milestone 1. For example, this is a texture manager. Each texture class points to an ASIO texture object, and this is a concrete texture manager. And for each manager, I use the object pool to implement the prototype manager. They are reserved linked list and active linked list. The pattern of this is object pool. And this is image manager. The same as texture manager, but each image class points to a texture manager. And this is a game sprite manager. Game sprite is derived from an abstract class named sprite base, and each game sprite points to an ASIO sprite object. And this is a box sprite manager. Box sprite manager points to a ASIO sprite box object. And this is a game object manager. Each game object node points to a game object, which is an abstract class, and many kinds of concrete game object is derived from game object. They are squid, crab, octopus, and now game object. Each game object points to a proxy sprite, and this is a sprite batch manager. Each sprite batch points to a SB node manager, and each SB node manager controls SB node. SB node points to a sprite-based abstract class. And the game sprite, box sprite, and proxy sprite are derived from the sprite base. So, sprite batch manager will control all of the game sprite, box sprite, and the proxy sprite. And this is a timer manager. Each time event points to a command class, and a concrete command class is derived from this command abstract class. For example, this animation sprite command class is responsible for animation of each sprite. It points to a game sprite and points to a list of images for the relative sprite. And when the time is triggered, the animation sprite will swap the image of the game sprite and it will change the image to the next images so that the animation can be implemented. The motion alien grid command class is used to move a whole grid of 55 aliens on the screen. This class points to a composite pattern. This motion alien grid command class points to a composite tree structure that holds 55 aliens on the screen. And when the execute method of this class is called, it will call the move method of composite class such that each alien will be moved to the next position on the screen. And I have used 6 kind of patterns in milestone 1. They are singleton pattern, alien factory, proxy pattern, command pattern, composite pattern, and priority queue timer pattern. First, I used the singleton pattern for every managers. For example, texture manager. The constructor is private and there is a public method named create. When this public method is called, the whole texture manager will be created and the instance will be saved and will be assigned to the private static instance variable, and all of the operation is declared as public static like destroy and find and remove. And if client call these methods, the relative operations will be done inside of this texture manager class. So that's the benefit of singleton pattern. Now, next is alien factory. Alien factory is used to create a different game object, like a squid game object, a crab game object, an octopus game object. And when the game object is created, they will be attached to the game object manager, and they will also be added to a composite pattern tree, and they will the proxy sprite that the game object points to will be attached to sprite batch manager. And the proxy pattern is used to wrap the game sprite here. And the proxy sprite has x coordinates and y coordinates. And when we want to move a game sprite, we just change the x and y of proxy sprite, and after that the new x and y will be mapped to the x and y coordinates of game sprite, such that the game sprite will be displayed at a new position. The next is a command pattern. I use a command pattern for a timer. Just like I said before, the animation sprite is a command class, and motion alien grid is also a command class. When the time event is triggered, it will call the execute method of command. Then in execute method, the animation will be implemented, and the grid of aliens will be moved to the next position. Next is the composite pattern. I use composite pattern to create a tree structure in such that it can save a grid of 55 aliens. There are 5 rows and 11 columns for the grid. The first row is squid, the next 2 rows are crabs, and the last 2 rows are octopus. And each column is a composite class instance, and the whole grid is also a composite classes. And the leaf of the composite pattern is concrete squid class, crab class, and octopus class. And I use the priority queue in Timer Manager. The Timer Manager controls all of the time event, and the time events are sorted by trigger time in ascending order, such that when we traverse the time event to find which time event should be executed, and we just need to traverse the time event from the beginning of the linked list and until the first time event whose trigger time is greater than the current time. That will save operation time. And in order to move the grid of 55 aliens on the screen, I do it in the motion alien grid. In this command class, I just calculate the delta x and the delta y, which means the moving distance that an alien have to move. And after I calculate the delta x and delta y, I just call the move method of the grid, namely the composite class instance, and the composite class will traverse each leaf and make them move to the next position. And after the time event is executed, the time event will be added back to the time manager linked list with the new trigger time. That's all. Thank you.